Hey guys, it's Mr. Walker here, and thanks for joining me yet again for another awesome math lesson. Hopefully it's an awesome math lesson. In this lesson, we're going to be building on what we learned in a previous lesson about dividing decimals, okay? And how we can divide decimals in much of the same way that we just divide whole numbers, right? We're taking a number and we're dividing it into groups, right? Equally into groups. Well, today we're going to be doing some more of that and modeling it with the place value chart and dividing it into the different groups. But we're going to be seeing how we can connect what we're doing there to the standard algorithm for division. And the standard algorithm for division is something you might have heard of before. Maybe you've seen it come into play with like dirty monkeys smell bad or something like that, where we're dividing, we're multiplying, we're subtracting, and we're bringing down, and then we're going to repeat that process over and over again. So that's called the standard algorithm, and we're going to make some connections between what we're doing with the place value and dividing things up and how we can actually use the standard algorithm to help us divide decimals. So if you would, I'd like you to make sure that you have your place value chart with you. If you do happen to have place value discs and you want to use those, you can, but we can also just draw them in, which is what I'm going to be doing, a little bit of both there. So once you have those things gathered and you're ready to go, go ahead and click continue and we'll keep watching. Alright, so we're going to start right off with an example here of 6 and 72 hundredths divided by 3. So I have my place value chart here. I also have 3 groups because that's what we're dividing it into, right? Into 3 equal groups. So I'm going to go ahead and use my place value discs to make the number 6 and 72 hundredths on my place value chart here. And then we're going to take a look at how we can divide that. So once you guys go ahead and represent that number on your place value chart, and then we'll come back together and take a look at our next step. Alright, so I went ahead and represented my number of 6 and 72 hundredths on my place value chart here. So I have 6 ones, I have 7 tenths, and I have 2 hundredths, okay? So we're going to start over here with our ones in the ones place, okay? And we're going to divide those ones evenly up into 3 groups, okay? And what I'm literally going to do is just draw those 6 ones into each group. So I want you guys to do that as well and tell me how many ones are we going to end up with in each group. Well, if I were to drag these out, so I'd have 1 here, and 1 here, and 1 here, so I would have 2 in each group, okay? So 6 ones divided by 3 would give me 2, okay? Easy enough so far, and that went in nice and evenly and not a problem there. So following up with my standard algorithm over here, I forgot to jump right off with that. But if we had 6 and 72 hundredths, and we were dividing that by 3, we would have divided those 6 ones into 3 groups, and there would have been 2 in each group, right? Which is what we're seeing here. 2 in each group. And how many of those ones were we able to share? How many ones in total? Well, there were 6, right? Because 3 times 2 equals 6, so then we go ahead and subtract. And 6 minus 6 equals 0. And there were no ones left, right? We were able to share all of them. So for the next step, we're going to jump back to our place value discs, divide, and then I'm going to show you where that lines up in our standard algorithm. So now we're going to move on to our tenths. So here we have 7 tenths, and we're going to divide those into 3 equal groups, just like we did with our 6, right? So how many tenths can be shared with each group? Go ahead and think about that, divide yours out, and then we'll come back and talk about it. Okay, so if I was going to share these tenths, I'll do 1 here, 1 here, 1 here, so they all have 1, so that's good, and I could do another one, 1, and 1, and 1, and then that's even, so there we go. So I could share that. If I brought this guy down, I would have an uneven amount, right? I would have 3 in here and all the rest would have 2. So I'm not going to do that. I want to make sure that I'm sharing these things evenly, okay? So seeing what I did, I was able to share 2 tenths into each group, right? So 2 tenths in each group, and I was able to share 6 tenths, right? 1, 2, 3, 4, 5, 6. I was able to share 6 tenths. But that left me with 1 tenth left over. I wasn't able to share all of them, right? That left me with 1 tenth. And we're subtracting those 6 tenths from the 7 tenths that we have, and again, it's left us with 1 tenth, okay? So there's 1 tenth left to share, but can we share that 1 tenth between these 3 groups? All right, that's not going to work. There's not enough of them to go around, as we saw a second ago. So what can we do instead? Let me know if you have any guesses out there, and then we'll talk about it together. All right, perfect. What I could do is I can take this 1 tenth and I can unbundle it into hundredths. Okay, so now I can share it as a hundredth, right? We're making it basically a little bit smaller. Okay, breaking it apart. So that 1/10 will turn into 10 hundredths. Okay, so I have that 1/10, I turned it into 10 hundredths, and now I have my 10 hundredths here plus the 2 hundredths that I already have, which would make 12 hundredths. Similarly, over here, if I was following my steps, I would have divided and then subtracted, which I got my 1, and then I'm going to bring down this 2, which means I would have 12 left to divide, 12 hundredths left to divide apart, divide into those three groups, okay? So can I share 12 hundredths equally among these three groups? Well, I'm going to try it out. You guys try it out, and then we'll come back together and talk about it. All right. I don't know about you, but I was able to divide up those 12 hundredths into those three groups equally, and I was able to put 4 in each group. So that worked out nicely. That was perfect because 12 divided by 3 equals 4, right? So coming over here to my standard algorithm, I was able to put 4 in each group, which gave me a total of 12. That's how many I was able to share. Subtract that, and I'm left with 0, right? No remainders. There's nothing left over. Even though this 10th is sticking out here, it's only here. I had unbundled it to put him into the hundredths, so he kind of did go away, even though he didn't totally go away on my picture there. But there you could see how I made the connection between my place value chart and my groups and my place value disks and the actual standard algorithm, which is kind of cool. The place value disks and the place value chart kind of show the behind the scenes of why the standard algorithm works the way it does. Now, I forgot one thing that's very, very important, and that's the answer. Now, the answer, if I come over here to the standard algorithm, so I had my decimal point was here, right? So I'm just going to bring that straight up, and my decimal point is still going to be there. So my answer to this, according to the standard algorithm, is 2 and 24 hundredths. 2 and 24 hundredths. Now down here, if I were to count them up, I have 1, 2, 3, 4, 5, 6, 7, 8 place value disks, right? But that's kind of misleading because that's not quite what I have. What I have is, if you remember, when we started, if you remember the color, these green ones were 1s, right? So that meant I had 2 1s. These were my tenths, 2 tenths, and then I had 4 hundredths. So it is the same answer. We just have to remember what the value of each one of those dots were and why it worked out that way. So I have 2 24 hundredths, the same answer as I got over here. All right, perfect. Let's take a look at another example real quick and see if that helps to solidify things a little more. It helps us to really kind of get a good grasp on what's going on. Okay, so for this example, we have 20 and 8 hundredths divided by 8. 20 and 8 hundredths divided by 8. So I'm going to start by writing my standard algorithm up here to get that started. So I have 20 and 8 hundredths, and that's going to be divided by 8. Okay, so knowing my standard algorithm, I can, or if you guys remember how to do it, you could do 8 goes into 2, well, it doesn't go into 2, but it can go into 20 and blah, 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 blah. But I'm going to still use my place value chart to kind of help me keep track of things and really see the why behind why that standard algorithm is going to work. So the first thing I'm going to represent here is I'm going to use my place value disks to map out my 20 and 8 hundredths here on my place value chart, so I can use that to divide them up into my 8 equal groups, which I have going on down here. So why don't you guys give that a try? I'm going to build mine up here, and then we'll talk about it. All right, so I have my 2 10s to represent my 20, and I have my 8 hundredths for my 8 hundredths that I have here. I don't have any 1s, I don't have any tenths, and that's okay. Another thing I'm going to do, though, just to help me remember, forgot to do this earlier, is I am going to write my steps for division that I like to remember, which is dirty, monkeys, smell, bad. I know, sounds silly, right? But this stands for divide, multiply, subtract, and bring down. Okay, and we're going to see all those steps come out to play here as we go through the standard algorithm. All right, so I'm going to start with my 10s, and I'm going to divide them into these 8 groups, right? But can I do that? Can I evenly put these 2 10s into these 8 groups? I can't, right? So I'm going to have to think of these 2 10s in a different way. I'm going to have to move them into my 1s. So if I were to break up one of these 10s into 1s, well, that would give me 10 1s, right? All right, I'm running out of room, so I'm kind of stacking those 1s on top of each other. So there's 10 1s for that 10, and then I actually have another 10, so I'm going to have to do that again. So I'm going to end up with 20 1s. And they're kind of starting to overflow, but that's okay. And the reason being that I have to have 20 1s is because if I look over here and I start, can 8 go into 2? No, it can't. But can 8 go into 20? Sure. 20 can be divided up into 8 groups. 2 can't be. So that's why I took those two 10s and I made them into 21s, because now I can divide. So now I'm just going to start taking these 10s and evenly distributing them amongst my 8 groups. All right, I went as far as I could, and now I have 4 1s left over, but I won't be able to put them into these groups evenly, right? I'm going to have some without 1. So I'm going to stop there for now. I'm going to think about this for a second. I was able to take those 20 1s and divide them into 8, or divide it by 8, and that gave me 2 in each group, right? 2 in each group. And when I did 2 in each group, so I did 8 groups of 2, well, that got me to 16, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So now I did my divide, I did my multiply, I'm going to do my subtract. 20 minus 16 would give me 4, which is the 4 that I have left over here. So what am I going to do with those 4? Can't divide them up into the 8 groups, so what am I going to do with them instead? Exactly. I'm going to move them into my tenths. I'm going to turn them into tenths to make them a little bit easier to work with. So, that being said, if I took these 4 1s and turned them into tenths, I would have 40 tenths. Alright, so I took those 4 1s, I divided them into tenths, and that gave me 40 tenths. Quite a mess going on there, but you kind of get the idea. Okay. And the reason being is because, as we would see over here, I would have to bring down this 0, and I would end up with 40, okay? So now I'm just subtracting through and I'm dividing through. So 40 tenths, and I'm going to divide those up into 8 groups. How many tenths are going to be in 8 groups? How many tenths can I put evenly into each group? Alright, so now I've taken those 40 tenths and I've divided them evenly into those 8 groups, and each group is going to get 5. 1, 2, 3, 4, 5, 10, 15, 20, 25, 30, 35, 40, right? So each group got 5. 5 times 8 gave me 40. I can subtract and I have nothing left, which is exactly what shows over here. I got nothing left. I put them all in there, right? Perfect. So now I'm going to move on to my hundredths. So I'm going to bring down my hundredths. It shows me I have 8, which is what I have here is 8. So I'm going to divide those 8 hundredths up into my 8 groups. So 1, 2, 3, and there you have it. Each one of those 8 will go into a group. It'll be 1 in each group. So I have divided things up, and I'm going to move my decimal point up here, which means I'm going to get 2 and 51 hundredths as my answer. Just to make sure I did this correctly, here's my 1s. There's 2, there's 5 tenths, and there's 1 hundredth. So that would be the same thing as 2 and 51 hundredths. So you could see I could use my place value chart, I could use my place value discs and groups to help me divide. I could also use a standard algorithm which kind of walks through the same steps just in a different way to help me divide decimals as well. So hopefully this is starting to click, this is starting to make sense. If you guys have any other questions, comments, or concerns, please let me know. I'm going to encourage you guys to try this out a little bit on your own and see if it makes sense, and follow up with some of those practice activities. If you need anything at all, please reach out and let me know, and I thank you guys for watching.